I have? Now remember, this whole rest of the chapter, we're talking about how to do what? No. Solve quadratics, right? We've talked about factor and solve. We've talked about backwards PEMDAS or SADMAP, right? Taking square roots and stuff. And so today we're going to talk about complete the square. Complete the square is a method that will always work. It gets kind of messy, but it will always work, okay? So let me start by showing you what a square looks like and what we're talking about. What we're essentially doing is we are setting up this equation so that we can SADMAP it, okay? This is where you have to remember perfect square trinomials. Remember I told you we were going to get to that lesson where you'd have to be able to recognize them. Surprise, you're here. Okay? So if you look on the left, do you recognize that the left side is a perfect square trinomial? Why? X times 4 is 4x, doubled is 8x. So tell me how that would factor. That's a pretty easy solve now, right? If I needed to solve that equation, I would go through and do what? Square root both sides. What is the square root of 25? Or? -5. 5 or -5, right? We're talking about 2x intercepts, so we're talking about 2 points. And so when I add 4 to both sides, I end up with 4 plus or minus 5. Okay, and I do want you to understand what that means, because when we start quadratic formula on Tuesday, you'll need to understand. This means literally 4 plus 5 is 9, or, right? Okay. Yes, that means that my parabola is crossing at 9 and -1. I don't know what the bottom's doing. But those are my two solutions. That's why it's important that you have both solutions, okay, so you know. So, huh? No. But I mean, this whole chapter is about graphing and quadratics and things, so you will have to graph on the test. All right. So the problem becomes when this is not a perfect square trinomial. So what we're going to do is we're going to complete the square, meaning we're going to find the number that we can put here to make it a perfect square trinomial. We're going to force it to be a perfect square trinomial. So before I show you in a whole big equation form, I want you to look at something. If I needed to put something in that blank to make that a perfect square trinomial, how did you get that? So you're doing a little formula in your head, right? You are. You are. If I wanted to come up with a formula, I'm going to call this C. I'm going to say it's a good C because it's going to make a perfect square trinomial. What? Tell me again what you're doing. You took the middle number. And you did what? We'll call the middle number B. Mm-hmm. You did. That's exactly right. Good job. That's the formula for finding a good C. A C that is going to force it to be a perfect square trinomial, okay? And for all these, we're going to assume a leading coefficient of 1. So if it doesn't have a leading coefficient of 1, we're going to have to force it to have a leading coefficient of 1. Yes. So if B is 0, C is yes, but then it wouldn't be a perfect square trinomial. So it's always going to be yeah. What goes in the blank? Oh, no, not 81. Ooh, this one's tough. Yeah, it's not going to be pretty, but can it be done? It can be done. What would it be? Hang on. No decimals. You mean improper fraction. Look, y'all are making this infinitely harder. Yes, thank you. 81 over 4. Now let me take it one step further. Factor it. Remember how you factor a perfect square trinomial? What's the square root of the first? 1. What's the first sign? What's the square root of the end? What? It's really not hard. Don't make it harder than it is. Look at the first one that we found a good C for.
Are we actually going to have to...
So it's a perfect square trinomial, and we know that because we used the formula for finding a good C here. So when you have a perfect square trinomial, you do the square root of the first, the square root of the last, and you keep the first sign here squared. Same here, if I was factoring this, it would be x first sign 8 squared.
Because and then the square root of the last is just the answer. Is just the
What you did before you squared it. Yeah, divided by 2. The middle divided by 2. Yeah. You're just going to have, you'll see why you have to be able to find it squared also in just a second. Okay? Let me put one up here. And I want you to tell me if it's a good C or if it's a bad C. Wills, why do you know it's going to be a bad C?
Because you wouldn't have said a good or bad.
Yeah, it's going to be. That's not.
That's a bad one, right? That's not even a perfect square. So I know right off the bat, and let's say that this equals 0. Okay? I know right off the bat that this is bad. Oh my gosh, it's bad. It's not even a perfect square. So I'm going to get rid of it. But because I'm in an equation and everything's equal, I can't just get rid of it because I don't like it. What do I have to do with it? You can, and you do. Okay? I'm going to put it over here. And I'm going to say, nope, get away, leave me alone for right now, okay? So I have x squared minus 12x. I don't have a c right now. I will have a c in just a minute. And over on the right side, I've got negative 50 because I moved that 50 over. Does that make sense to everybody? So now I need to know what could I put in this blank that would make it a good C? Yes, if it's bad, you're going to do this. 36. Because 12 over 2 squared is 36. But because I'm an equation again and I have to stay balanced and nice and equal on both sides. I'm going to write you some steps in a minute. I just kind of wanted us to think through one first. Yes, you would. So what we're going to do is we're going to factor the left side. How does that factor?
It's x.
You always add the 6.
X minus 6.
What does it equal?
14.
Can you solve that now for x? Sure. I took something that was a CBF problem and made it factorable is what I did. Negative 50 plus 36. Yeah.
So anytime you find the C, you have to put it in.
Yes, you have to put it on both sides because it's an equation. You can do whatever you want to, you just have to do it to both sides. You're adding the good C to both sides. That's what you're doing. All right, now I'm just going to run through and finish solving this. This should be an easy solve for you. I got an I here, right? But I can't take anything out of it. So I'm just going to add that 6 to both sides and have my solution be 6 plus or minus I root 14. Now, if your head is spinning, it's okay. I'm going to give you some steps to go through. That one, I just wanted you to kind of think through because it's a very logical process that you're doing. if you understand as you go. So I wanted you to see it from start to finish before I gave you steps, okay? But I am going to list you out some steps so you have something to refer back to in your homework. All right. How to. I know.
Can you go back to 131?
Yeah. How to complete the square. Steps, and we'll do an example. I'm going to put a little bit more complicated example on here, one that we have to take care of a leading coefficient and stuff so you can see what happens in that scenario. Let me find a good. All right. If there is a leading coefficient, that's a big if, okay? A lot of times it'll just be a 1, but if there's a leading coefficient, you have to get rid of it before you complete the square. Now, we just determined we can't just get rid of something because we don't like it, unfortunately. That took a dark turn fast. So, how do we get rid of the 2 there? Because it does have a leading coefficient. Divide everything by 2. And when I say everything, I mean everything. Left side and right side, every term. There could be a 0 on the right and there could be a number over there. It doesn't matter. We're not even worried about that right now. Right now we're worried about get rid of that leading coefficient, okay? So I end up with x squared when you are to the point where you have no leading coefficient, we're ready to check our C. Okay? Check your C. If it's a good C, now what do I mean by good C?
If it works.
If it's a perfect square trinomial, right? If it square dances, okay, if it meets all those criteria, if it's good, go ahead and factor and solve.
Wait, hold on.
And stop there.
It's divide by whatever the leading coefficient is. If that was like a 9, you
Yep. Now, if it's a bad C, and if I'm asking you to complete the square, it's going to be a bad C. Okay? So if it's bad, now we would stop here. Don't go any further if it's a good C. But if it's a bad C, I need to move it. I like to move it. Move it where? To the other side. All right, so here I have a hole now, right? Okay, but I have -7 on this side. Now, I always tell students when you're first learning to complete the square, it may help you if you add a blank on both sides to remind yourself when I find what goes in the hole, it has to go on both sides. It doesn't just, you can't just throw it on one side because you want to. Okay? You find your good C. How do I do that? I'm going to say find good C and add to both sides. Am I going too fast? It's 4. You're exactly right. So here my good C would be, if I took 4 and divided by 2 and squared it, it would be 4. It's got to go here, and it's got to go here. Now it's an easy solve from here. It's all downhill from this point. Because now all I need to do is factor and solve. And since it was a perfect square trinomial, it's an easy factor now. So I have, factor it for me. What's it look like? x plus 2 squared. All those radical properties are going to come into play. Can't forget anything in Algebra 2 because we use it. Square root. Don't forget your plus or minus. And now what? Subtract 2. Tell me what you think. It's not that bad? You think so?
I don't know why.
You do it?